Today we're going to tackle about how to determine whether a function is continuous at a number or not. A graph for a function that is smooth without any holes, jumps, or asymptotes is called continuous. A continuous function is a function that does not have any abrupt changes in value, known as discontinuities. More precisely, a function is continuous if arbitrarily small changes in its output can be assured by restricting to sufficiently small changes in its input. To determine whether a function is continuous at a number or not, there are three things that has to be true in order for a function to be continuous. Fc must be defined. The function must exist at an x value c, which means you can't have a whole-in function such as 0 in denominator. The limit of the function as x approaches the value of c must exist. The left and right limit must be the same. In other words, the function can jump or have an asymptote. The mathematical way to say this is that limit of function as x approaches the value of c must exist. The function's value at c and the limit as x approaches c must be the same or equal. We can define continuous using limit. A function f is continuous when, for every value c in its domain, fc is defined, and the limit of fx as x approaches c is equals to fc. The limit says as x gets closer and closer to c, then fx is getting closer and closer to fc. We have to check from both sides. As x approaches c from left, then fx approaches fc. And on the other side, as x approaches c from the right, then fx approaches fc. If we get different values from left and right, which is a jump, then the limit does not exist. And remember, this has to be true for every value c in the domain. Here are some of the examples. F of x is equals to x squared minus 2x over x3 at x is equals to 4. You can substitute 4 into this function. If you look at the function algebraically, it factors to this. Nothing cancels, but you can still plug in 4 to get f of x equals 4 times 4 minus 2 over 4 minus 3, and 4 times 2 over 1 is equals to 8 over 1, which is 8. Both sides of the equation are 8, so fx is continuous at x equals to 4. If any of the above situations aren't true, the function is discontinuous at the value of x. F of 4 is equals to the limit of f of x when x approaches 4. Here's another example. F of x is equals to 2x minus 4 over 3x minus 3 as x is equals to 1. You can substitute 1 into this function. F of 1 is equals to 2, substitute x by 1 minus 4 over 3, substitute x by 1 minus 3. 2 minus 4 over 3 minus 3 is equals to negative 2 over 0. This function is undefined because its denominator is 0, which means it is not continuous, or we can also call this discontinuous. And that's all for today.